Hi, welcome to the video on theory of computation, and this is series number 4. My name is Hera Shaheen and today I will discuss problems based on DFA. In the last problem we were discussing how we can construct DFA over the alphabet AB of length at least 2, at most 2 or equal to 2. In the problem like this, what we have to do, we have to find the skeleton, that what is the base of this language or strings. Okay, we have saw 3 problems where length is less than equal to 2, length of string is equal to 2, length of string is less than equal to 2, and length of string is greater than equal to 2. Equal to 2 means the length is exactly 2, less than equal to 2 means at most 2, and greater than equal to 2 means at least 2. Means 2, 3, 4 and so on. So these two are finite language, but this is infinite language. What you have to do in case of finite language and in case of infinite language, how you find a skeleton of this? What you have to do in case of infinite language, you consider the smallest string and make the skeleton using that. In case of infinite language, and in case of finite language, take the highest string and make the skeleton using that. Suppose what I told you that in case of infinite language, this is infinite language, this is finite, this is finite. In case of infinite language, take the smallest string. In this case, what is the smallest string? AA, AB, BA, BB. These are the smallest strings, and others are greater than this. This is the smallest string. In this, what I told you, that take the highest string, biggest string. In this only this is smallest and biggest the same. AB, AA, BA, BB. In this case, epsilon, A, AA, AB, A, then B. This is 0 length string. This is 1 length string, 1 length string, 2 length string, BB. So in this case, this is the smallest string, and in this case, all are smallest. That's why for this we had to use A comma B, A comma B. This is Q0, Q1, Q2, and another state is dead state. A comma B, A comma B. For this, so this was the skeleton. For this is your skeleton. Okay. What is this? This is initial state as well as final state. Okay, and now A, B, it has to this is also final state Q0, Q1, Q2. There are three final states A, B, and one is dead state A, B, A, B. Now this one, what I told you in this, that we take the smallest string as its skeleton, and the smallest strings are these things. So again, what we have to do, Q0, A, B reaches to Q1, this is initial state, A, B, first symbol, second symbol, it reaches to final state. Okay, this is your skeleton. And now anything more than this, suppose A, this A, and one more A, it has to accept everything A, B. So this is your skeleton here, this is your skeleton here, and this is your skeleton here. Write it down that in case of infinite language, the smallest string is your skeleton, and in case of finite language, the biggest string is your skeleton. From this you can start making DFA. So make a note of it. I will erase it and then proceed. Now what you see here, that when mod of W means length of string, word W means word means string. So length of string is equal to 2 when length of string is less than equal to 2. Then what you find here, that the number of states required here is 1, 2, 3, 4. Here also, in this case also less than equal to 2, the 1, 2, 3, 4. These are minimal DFA. So how many states required here is 4, there here also it is 4. But in this case, when you need mod of length of string is greater than equal to 2, it means at most 2. Then what is the how many states required? 3. Yani ki 2 plus 1. So you can say, in general you can say that if your mod of W is equal to n, then number of states required is n plus 2. When mod of W is equal to W is n nahi, n plus 2 is okay. When mod of W is less than equal to n, then also the number of states required is n plus 2. And when mod of 2 is greater than equal to n, then number of states required is n plus 1. Okay, so make a note of this thing. You can check it also, that if length of your string is 3, then you need 3 plus 2, 5 states. and when length of your string is less than equal to 3, then also you need 5 states. And if question says that your length of string should be greater than equal to 3, then number of states required will be 4 when n is equal to 3. And similarly we can find for others. So in general you can remember this, that if your length of your string is n, then number of states required will be n plus 2. When length of string is less than equal to n, then number of states required is n plus 2. When length of string is greater than equal to n, then the number of states required will be n plus 1. Okay, so these are the number of states required in your minimal DFA. Okay, now let's see one problem which says that construct a minimal DFA where W belongs to AB and length of W mod 2 is equal to 0. What does it mean? It means that W belongs AB means your alphabet is A comma B. Means alphabet contains the symbols A and B only. And mod W, this means length of string mod 2 is equal to 0. This means your length of string mod 2 is equal to 0. It means when we divide the string by 2, remainder will be 0. When the remainder when we divide by 2, the remainder is 0 of which type of number? Even. It means the length of your string is length of string is even. Whenever you are given that length of W mod 2 is equal to 0, it means length of string is even. And if it is given like this, that length of W mod 2 is equal to 1, then it means it is odd. What is odd? Your length of your string. So in this question you are given that length of string mod 2 is equal to 0. It means their length of string is even. Even means your length of a string should be 0 or 2 or 4 or 6 or 8 or so on. Means length can be 0, 2, 4, 6, 8, and it has not mentioned anything that it will be A only, it will be of A only, or it will be of B only. So we will consider both of them, both the symbols A and B, but we have to keep in mind that it will accept only those strings whose length is this type, whose length is even. So it means what will be the string in our language? L. It will be epsilon. 0 length means epsilon 2 length. It will be AB, BA, BB and AB, BA, BA, AB, AB, AA. This is 2 length strings, this is 0 length strings. Now 4 length string will be AAA, AABB, AA, AB, A, B, A and so on. This is 4 length string, and likewise your string will go on. But you have to keep in mind that it will not accept these strings of length 1, of length 3, of length 5. Here also it says that so on. It means it is infinite language. Infinite language, in case of infinite language, what I told you, to find the skeletal, we should always find from the smallest string. So here the smallest string is this one. This is epsilon. Epsilon is what? zero length string, means it is not accepting anything and it is going to final state. So whenever there is a epsilon or null string in your language, what you have to do, make the initial state as also final state. So this is initial state as well as final state, and now name it as Q0. Now it accepts at least AB, BA, BB. So what you have to do, Q1 and Q2 to accept A, B, or AA. To accept A, write it A comma B here, and to start with B, write B here comma B, so BA or BB. Here your string will be epsilon, and here A, B, BA, BB. Okay, and now for this 4 length string, what you have to do, you have to make one more state on A and make it Q3, A comma B, either A or B, it goes to Q3, and again on A comma B it will go to Q0. See, and this is the final state. Why I am making like this? We can make like this also. I am erasing it. Okay, I will again make it this diagram, or you just go back and see. We can do like this also, that it accepts again 2 more symbols, then it reaches to final states. This is Q3 and this is Q4. A, B, and A comma B. Here 0 length string, here 2 length string, 4 length string, not A comma B. We cannot write here A comma B, because if we write A comma B here, then 5 length string will be also accepted. So we cannot write here A comma B. What we have to do for the other strings, that if more string comes, suppose A, this type of string has to be rejected. What it has to do, here till here you have seen 2 A's and 1 more A comes, and after that there is no symbol, then it should go to some state like this one, and after that no symbol is there, so it will remain here, it will not go further. So this is not the final state. Any string to be acceptable, it should go from initial state to final state. It should reach to the final state. Okay, so to reach to the final state, the string should be reachable to the final state. But this string is not reaching to this state Q4 or Q2. Q2 it is exceeding this length. Till Q2 there are only 2 length strings, but it is 3 length string. For 3 length string it will go to this state, and this is not the final state. So this string will not be accepted, this string will be rejected. It's not necessary that it should go to the dead state. It should reach to the final state. If it reaches to the final state, then that string is acceptable. If it does not reach to the final state, then that string will not be accepted, it will be rejected. Here string is reaching to the final state, AB, AA, BA, BB. These strings are reaching to final state. Epsilon, null string, is also reaching to final state. That's why this is acceptable. And but what I want to tell you that this is not the minimal DFA. To make the DFA minimal means to make your states as less as possible. Then you can get many DFA. Okay, for this one language you can get many DFA, but minimal DFA is only one. So, by practice you will understand what is how you can find the minimal DFA. Just follow my steps here. What you do, you remove these things from here and just make a state Q3, and from Q3 to Q0 A comma B, A comma B, it will reach to the final state. Q0 is also final state. Any even length string will be acceptable here now. Suppose epsilon comes, so it is reaching to the final state. Here one length string, it will be remain in Q1, it will not go to the final state. If A comes, where it will go? It will go to the Q1 only. This will be rejected. A, B, A, B. This is A and B. This one and this one. It will reach to the Q2. Q2, it will reach to Q2, so it will be acceptable. Why it is acceptable? Because it is two length string. What it is saying that the length of your string should be even. Now suppose three length string comes. A. So A, and again A comes. So where it will go? It will be at Q3, which is not final state. So again it will not be accepted, it will be rejected. The string which starts from initial state and reaches to the final state, then only that string is acceptable. So this is not acceptable. Suppose your string is A, B. Then this A, B. So it will be accepted. Take another example of 6 length string. Or take another example of 5 length string. This A, B, A, it will come to Q1. Q1 is not final state, so this string will not be accepted, it will be rejected. Now take another example, A, B, it is 6 length string. For 6 length string, start from the initial state, A, B. It will reach to the state Q2, and Q2 is final state. So this string will be acceptable. This string will be acceptable, and so on. It will accept 0 length string, 2 length string, 4 length string, 6 length string, 8 length string, 10 length string, 12 length, and so on. That's all for today. If you have liked my video, don't forget to hit the like button and subscribe to my channel. We'll do more problems in the next video. If you have any query, write it in the comment section, and you can ask any related problems also. So thanks for watching. Okay, thank you.